Perfect. Hello, everyone. My name is Amandeep Singh Hira. I'm a fourth year student in molecular, cellular, and developmental biology here in Alberta. And I've been in Vishal Lab for almost a year now. So today I'm just gonna present something on Arduino microcontrollers, and we're gonna test it and build something with it. So just as an introduction, Arduino is an open source electronics platform. It's really easy to use. Anyone can use it. And since it's open source, so anyone can just download the schematics from arduino.cc and start building with it. So on the market, you can see some of the Arduino-like products like Algo or FreeNove, which is basically Arduino, but by different company. So yeah, so those are really good products and pretty cheap as well. This Arduino Uno costs only like $10, $20, like not Arduino, but a FreeNove can cost $10, $20. Arduino is like $50-ish. Okay, so let's dive into the basic components of Arduino real quick. So first is the microcontroller, which is the brain of Arduino. So Arduino Uno uses RT-Mega 328, which is called like the brain of the Arduino, which is gonna perform all the calculations. It also has some digital and analog pins, which is gonna be used for connecting sensors, LEDs, and all different kind of stuff. So it needs a power supply. Typically, it has a power supply like a power source, but also needs a power jack, or it can be powered through a USB port. And output of Arduino is either 5 volts or 3.3 volts. And as mentioned, USB, it can be used for programming the Arduino as well. And also has a reset button, just in case something goes wrong in the code, we can just reset the code without re-uploading it manually. Okay, and so it also has one 5 volts on LED, which is what we're gonna use in a moment. So it also has some, so to use to the sensors that to use with the Arduino, they're like a bunch of other sensors. Arduino has digital and analog pins that we know. So the sensors and shields are just gonna use those digital and analog pins to basically talk with the Arduino. So sensors either use outputs as a relative voltage, which can be read using analog pins, or uses data packages, which can be read using digital pins. And we're going to use some of these sensors today, like temperature and humidity sensor, in a second. So first, let's learn how to code in Arduino. It uses a C and C++ language, and it can be uploaded through USB. So no additional hardware is required, like some of the older versions of microcontrollers uses burners. So it doesn't need any burner or anything, but we can just upload our code through USB. And just a little bit about code. So it has two sections. One is setup, other one is loop. Setup is just the setting up for your device. It's just declaring your pins, your sensors, LED. This part only runs one time. So you're just gonna write your stuff which you want to run only once. And loop is the main part of the code. This loop runs forever while the circuit is like powered. And today we're gonna use Arduino IDE, but we can use any of the text editors on the internet. So hello world in Arduino, which is just a blinking LED code. So in the setup, we're just gonna declare the LED built-in, which I told you, like the 5 volts LED built-in. We're just gonna declare it as output. So we're gonna output through that built-in LED. And in the loop, we're gonna write digital write, which is just saying what we want the digital pin to do. So LED built-in, high, which is giving it high voltage, which is 1, and delay 100 microseconds, which is a second. And after 1 second, the digital write is low, which is just saying to turn off the LED, and then for 1 second. So it's gonna repeat between on and off in the 1 second time period. So now we have like basics of Arduino. Let's dive a little deeper. Let me introduce you to my friend Planty II. So It's a petunian species, and it's a 3 months old plant. You might be wondering why it's called Planty the Second, because it used to be a planty before it. It died of mysterious reasons. I don't know why. It might be because I didn't take care of it. But anyway, we gonna build something for a Planty the Second so that it can live forever. It's not gonna live forever, but I'm gonna make it live forever. So conditions for a healthy plant with flowers, because we love flowers. First is soil, water, and moisture. So it needs water. Also needs humidity because this it's like a summer plant, so it cannot survive without like low humidity in the low humidity. It also needs temperature, like regulated temperature. Vernalization, which is basically for plants, flowers, sorry. So you might be wondering like what's vernalization? It's just a period of cold temperature before a warm temperature, which basically says to the plant like it's time now, you can start flowering. Photoperiodism, which is light for the plant to make glucose molecules like through photosynthesis. And soil nutrients, it needs nitrogen, phosphorus, all different kind of stuff. Good circulation of air, carbon dioxide. Yeah, it needs carbon dioxide to do photosynthesis and all the other kind of things. But we're gonna focus only on first two, which is soil, water, moisture, and humidity. So soil moisture, we want the optimal soil moisture. Don't want the soil to be too wet, and we don't want it to be too dry for the plant. There are soil moisture sensors which either measures the resistance or capacitance, depends upon the model of the soil moisture sensor that you use. But we're gonna make our own sensor today. Okay, this is a simple voltage divider circuit with R1 as a known resistance of 2000 ohms and R2, which is the soil unknown resistance. So we can use our friend Ohm's law to find out what's the value of R2, because the current is constant because the resistors are in series. So you can trust me, this is the equation that we can drive out. R2 is equal to R1 into 5 minus V out divided by V out. Okay, just gonna write it down in the Arduino IDE. So check moisture function is just basically saying the same thing. So first, sensor is equal to analog read, which is gonna read the analog signals from the probe pin, and V out, VO, is sensor into 5 divided by 1023, which is the ADC converter. So analog to digital converter constant. And after that, the same equation that I show you. So after that, we're gonna read the signals from A0. So it should give us the resistance readings. Turns out it does. So at that point, I was reading 10,000 ohms for some reason. I don't know where it was, probably air. But yeah, let's take some values. To calibrate the sensor with variable amount of moisture, I took some soil in little cups, put like measured water into these cups and measured the resistance. So as you can see, as the water level increases, the resistance drops, which we know it does because water is a good conductor of electricity than soil is. And turns out I was looking a bit into how like reliable this sensor is. I found a paper which kind of did the same thing, but they probably had like better sensors than I do. And also the soil was kind of different because they use sandy soil, but you kind of see the similarity between the graphs. So it's a good thing that this sensor is working. Next thing, I forgot. So now we have the soil moisture sensor working. We're gonna connect it to the pump. So whenever we're gonna set the set resistance to 5,000. So if the resistance drops below 5,000, it's gonna turn on the water pump to water the plant. After that, it's humidity. So humidity can be read through a digital humidity and temperature sensor, also known as DHT module. So it has a thermistor inside, and also it reads through the resistance of air. It's really sensitive to the change in resistance, so we can see how humid the air is and what's the temperature of the air. And also, it's a digital humidity and temperature sensor, so we're going to use a digital pin now. Earlier, we used the analog pin. Okay, so it's a simple line of code, which basically says to read the temperature and humidity on digital pin 4. Turns out we can read it. Temperature was 23 degrees and humidity was 55 degrees, which is kind of in the range what I was thinking, because like room temperature is 23 and also like 55 degrees in the room. That's fine. Let's take some data from that thing. So I took two different conditions, one for like summer conditions, one for winter conditions. I made a graph out of these two. So as you can see on your right-hand side, we have this orange line, which is showing the winter conditions, and also this bluish part, which is showing a little bit of summer conditions through that sensor. So we can now use the same thing that we did with soil moisture sensor, using some nested if-else statements and also some loops to turn on humidifier when we want. But where's the fun in that? We're gonna use a flavor of machine learning known as SVM, supported vector machines. So it's gonna classify our data that we have into two different groups, and also creates a hyperplane between them. So we can now categorize data into like two separate parts. After that, let's dive a little bit deeper how we're gonna do it. So I'm just gonna use Python now because it's really hard to do on the Arduino. It only has one microprocessor, but we're gonna go into that after this. So using Python, sklearn, and pandas library. So first we're gonna train the model. So first I'm just gonna define the model. What's the temperature, what's the humidity, and ID is just 0 for summer conditions, so no humidifier needed, and 1 for winter conditions, which is like humidifier needed. So don't take summer and winter like summer and winter, just see them as humidifier needed or no. So we're just gonna define the variables in the data frame. X and Y. And now we're gonna train the model, which is shown here. Model is equal to svm.svc. Kernel is linear. There are other kernels as well, but for now, we're just gonna use linear for this model. Okay, so after training the model with the small data set over here, we're just gonna test it a little bit. So dot predict is used to test the model. So temperature is 13 degrees Celsius and humidity is 15%. So we're gonna ask the model, should we turn on the humidifier or not? And it says to turn it on. One is turn on. Okay, so now we have our model, but how are we gonna transfer it to Arduino? We cannot use dot predict on Arduino, so we have to take weights out of the SVM and somehow transfer it to our Arduino. Turns out there is a equation that we can use. It's called a decision equation. For a linear kernel, it's AX plus BY plus C. X is our temperature, Y is our humidity, AB is our coefficients, and C is our intercept. So we can take out the coefficients and intercept from our trained model. Here we can have these, here we have the coefficient and intercept, which is 0.073247 for temperature and negative 0.17705973 for humidity, and the intercept is positive 12.29943. And the probability can be found out using this sigmoidal equation. So this is gonna make graph in a sigma shape with a 0 in between. I'm sorry, 0.5 in between. Okay. So just gonna write this decision equation into a function in Arduino which is check humidity. So it's going to take temperature and humidity as variables, and basically this equation here. And after that, it's going to find the probability. So since this equation gave us a probability between 0 and 1, we want it to be either 0 or 1. So we're going to round the probability off. Okay, after that, we're gonna use that thing to turn on here humidifier. So it's just a if else statement, which is just gonna check if the probability is 1, it's gonna set the pin number 9 too high, which is our humidifier. So this is a little peek into the circuit. So it's taking the values from the DHT module, and it's gonna turn on the humidifier after that if the humidity is lower, or if it thinks that the humidity should be a little bit more than it's right now. Okay, that's all from my side. Here are the references for Arduinos. So arduino.cc, project hub.arduino, and the pictures, some of the pictures are from like yourmeme.com, and SBM documentation is from scikit-learn.org. And I would like to thank Team Artificial God, MarketDB, and Vegan for teaching me everything this summer, and also everyone in the Wishart Lab. And last but not least, Planty II for featuring in this presentation. Thank you, everyone.
Galina, if you can turn off the recording. Okay, maybe they have to edit it later. Yeah, that was a nice presentation, Amandeep.